everyone. Today we will be studying the chapter on water. We know water covers about 70% of the earth's surface and is essential for the survival of all life forms. About 95% of the earth's water is in the seas and ocean. The remaining 3% is fresh water, and most of this water, that is fresh water, we find it in the frozen condition on the mountains and the glaciers. Now, water we know is very essential for mankind. Water is a compound. Water is made up of hydrogen and oxygen, which combines in the ratio of 2:1 by volume. Hydrogen is a supporter of combustion. It is a combustible gas. It burns with a blue flame, we all know, and oxygen supports combustion. But when we have water, water is neither a combustible gas nor is a supporter of combustion. Now, looking into the physical properties, water is colorless, odorless, tasteless. It has a boiling point of 100 degrees at 760 millimeters of mercury. That is normal pressure. With increase in pressure, boiling point will increase. This is what we see inside a pressure cooker. In the pressure cooker, the steam is unable to escape, so the pressure increases. Boiling point of the water will increase, so food gets cooked faster. Decrease in pressure, the boiling point decreases. This is the reason why food takes longer to cook on a mountain. On top of a mountain, the pressure is less. Since the air pressure is less, the boiling point decreases. So we essentially need a pressure cooker to cook food on a mountain top. At the top of the Himalayas, the pressure is very low, so the boiling point of water is around 70 degrees centigrade. Presence of impurities also has effect on boiling and freezing point. In presence of impurities, boiling point will increase. So when we add salt to food, food gets cooked faster. Presence of impurities decreases the freezing point. Salt is added to ice. The mixture is known as freezing mixture, and it has a melting point of minus 115 degrees centigrade. Increase in pressure, the melting point decreases. That is the reason the skaters find it very easy to glide on the mountain tops. The next important character of water is anomalous expansion of water. What is this? Water has maximum density at 4 degrees, that is 1 gram per centimeter cube. But when temperature is lowered below 4 degrees, it starts expanding and finally forms ice at 0 degrees. This behavior of water is known as anomalous expansion of water. This is useful for marine life. When the temperature reaches very low, when the temperature is falling, when it is at 5 degrees, then 4 degrees, the temperature in the water is at 4 degrees, then the water at 4 degrees is heavy, so it will go down. The layer above that will be at 3 degrees, the layer above that will be at 2 degrees, above that will be 1 degrees, and finally you will have water at 0 degrees, that is ice will form. Once ice is formed, ice is a bad conductor of heat and electricity. Ice is a bad conductor of heat. So once ice is formed, the lower water layers are protected and the marine life can easily survive here. We know water has very high latent heat of fusion. What is latent heat of fusion of ice? It is the heat required to change ice to water at its melting point without change in the temperature. Ice, or rather water, has very high latent heat of fusion. It is 336 joules per grams or 80 calories per gram. We see the same amount of heat is released when water changes. Once ice is formed, ice is a bad conductor of heat and electricity. So, ice is a bad conductor of heat. So, once ice is formed, the lower water layers are protected and the marine life can easily survive here. We know water has very high latent heat of fusion. What is latent heat of fusion of ice? It is the heat required to change ice to water at its melting point without change in the temperature. Ice, or rather water, has very high latent heat of fusion. It is 336 joules per grams or 80 calories per gram. We see the same amount of heat is released when water changes into ice. That is the reason lakes and rivers do not freeze suddenly. Next, we have latent heat of vaporization. Water has very high latent heat of vaporization, that is 2268 joules per grams or 540 calories per gram. What is latent heat of vaporization? It is the heat required to change from liquid to the gaseous state. What is the use? Evaporation of sweat causes cooling effect as it takes away the heat from our body. Next, we have latent heat of condensation. It is the heat released when water vapor changes to liquid. Sudden release of latent heat of condensation causes violent torrential rain. Next one is specific heat capacity. What is specific heat capacity? It is the amount of heat absorbed when 1 gram of water is heated through 1 degree centigrade. The specific heat capacity is 4.2 joules for water. Water has very high specific heat capacity, so it is used as coolant in motor cars. It is used in desert coolers. This leads to land and sea breeze, modification of temperature of the surrounding areas. That is the reason summers are cooler and winters are warmer in places like Chennai and Bombay compared to Delhi. In water are crystals and crystallization. What is a crystal? A crystal is a homogeneous solid of definite geometrical shape. It has symmetrically arranged smooth plane surfaces which meet, forming the sharp edges. We have crystals of various shapes. Some are cubic like sodium chloride. It can be rhombic like copper sulfate, octahedral like ferrous sulfate. Now, next let us see what is crystallization. Crystallization is a process by which crystals of a substance are formed by cooling a hot saturated solution. It can be by cooling a hot saturated solution or slow evaporation of a saturated solution, or it is cooling of a fused mass, or it can be by sublimation. Next part is hydrated and anhydrous substance. What are hydrated substances? These are the substances which contains water molecules in them. The water molecules present in any substance is generally in the form of water of crystallization. What is water of crystallization? It is a fixed amount of water that is associated with some compounds which is an integral part of the crystalline structure. Some examples of water of crystallization, that is the compounds which contain water of crystallization, is your copper sulfate, 5 water molecules, that is your blue vitriol, sodium carbonate, 10 water molecules, washing soda, sodium sulfate, 10 water molecules, that is your Glauber salts. Now, if we take these substances in a test tube, like if I take copper sulfate 5 water molecules in a test tube and I heat it gently, we will find that the copper sulfate crystals becomes anhydrous, turns from blue to white, and deposits are there on the edge of the test tube, which is in the form of droplets of water. That is, copper sulfate 5 water molecules on heating changes to copper sulfate 5 and gives 5 molecules of water. Next we have the anhydrous substance. A substance is anhydrous if it contains no water. For example, salts lacking their water of crystallization. The term anhydrous is often applied to crystalline substances when the water of crystallization is removed. Now, how can we get these anhydrous salts? We can get by direct heating, by heating in dry and hot air. We can get it by heating under vacuum, by using some dehydrating or desiccating agents such as warm concentrated sulfuric acid. Some common examples of anhydrous salts are common salt, that is sodium chloride, niter, potassium nitrate, sugar, C12, H22O11, potassium permanganate, KMNO4, ammonium chloride, NH4Cl. Now, if we take some crystals of sodium chloride and if we heat it, we know it is an anhydrous salt. Initially, you will find some crackling sound, which is called decrepitation. Now, this sound is due to the breaking up of the bigger crystals of sodium chloride into smaller sodium chloride particles. Some terms which we come across in this chapter are efflorescence. Now, what is efflorescence? It is a phenomenon where a compound loses its water of crystallization on exposure to dry air. This results in loss of water of crystallization, so its crystalline shape is lost and it becomes anhydrous. Some common examples are sodium carbonate 10 water molecules in presence of dry air breaks up to give you sodium carbonate dot water molecule and 9 water molecules. Then we have copper sulfate 5 water molecules. This is blue in color. In dry air it breaks up to give you copper sulfate and the 5 water molecules are given out. This copper sulfate is white in color. Then if you take sodium sulfate 10 water molecules, it will give you sodium sulfate plus 10 water molecules. These salts over here you will find have lost their crystalline shape and have become amorphous. The next term is deliquescent. Certain water-soluble substances, when exposed to the atmosphere at ordinary temperature, absorbs moisture from atmosphere and becomes moist, lose their crystalline form and ultimately dissolves in the absorbed water, forming a saturated solution. The common substances which show deliquescence are sodium hydroxide, potassium hydroxide, ferric chloride, calcium chloride, magnesium chloride, zinc chloride. All of these show deliquescence. The next term we come across is hygroscopic. These hygroscopic substances are generally used as your drying agent. The substances absorb moisture from the atmosphere when they are exposed to it, but not enough to form solution. Such substances are your hygroscopic substances. Common examples are concentrated sulfuric acid, phosphorus pentoxide, quicklime, silica gel. Now you must be finding in the rainy season your table salt, that is sodium chloride, turns moist and finally you find it forms a solution. Why is this? This is because sodium chloride contains some impurities like magnesium chloride and calcium chloride, which are deliquescent. Sodium chloride is not deliquescent. Due to the presence of these impurities, they absorb moisture and makes the common salt sticky or in a solution state. We come across two terms which are your drying agent and dehydrating agent. A drying agent is the one which removes the moisture from other substances like the gases, and it is a physical change. It just removes the moisture. Example of drying agents are phosphorus pentoxide, fused calcium chloride, calcium oxide, concentrated sulfuric acid. While dehydrating agents are those which removes the chemically combined water molecules, that is the molecules of hydrogen and oxygen in the ratio of 2:1 from the compounds. Now they undergo a chemical change and totally a new substance is formed. Common examples are your concentrated sulfuric acid and alumina, that is Al2O3.